All right, this is section or problem 3 asking you to find the limit. And what I'm going to do in this video is give you some hints on how to approach these. Problem A is not too bad. You can just use direct substitution here. Problem B, you're going to want to FOIL out the numerator and simplify. And once you simplify, you will be able to use direct substitution. Let's see, for problem C, I believe you can just use direct substitution. For problem D, you need to approach this graphically. So I'm not going to show you the exact graph, and I don't want you to use your calculator. I'd like you to graph this with your knowledge of rational functions. What happens when you have a quantity squared in the denominator? What happens with the vertical asymptote? What happens with the end behavior? Think about what that graph is going to look like. The parent function is 1 over x squared, so that's my hint. So once you graph that, I think you should be able to tell what is going on with the limit as t approaches 6. Okay, let me get this squared in there better. All right, for E, you have two choices. You can multiply by the conjugate of the numerator, which would be 4 plus the square root of x, or you can do something really funky, which is factoring the denominator into the square root of x minus 4 times the square root of x plus 4. And then what ends up happening is you can factor a negative sign out of the numerator, which will give you the square root of s minus 4. And I'm hoping now you can see what cancels. And once you cancel, you can use direct substitution. For F, this is actually the signum function shifted right by 8. So it would be best to graph the signum function and determine the limit from the left. Remember that this 8 with the little negative sign means from the left. So figure out the limit from the left once you have graphed the signum function shifted right by 8. For G, you are going to want to multiply by the conjugate of the numerator, which would be this. So 1 plus the square root of 1 minus x squared. And remember, you're multiplying by a fancy form of 1. So we have to multiply by the conjugate divided by itself. Now, what you then have to do is actually FOIL the numerator, but do not FOIL the denominator. And then once you FOIL the numerator, you'll be able to cancel something out and finally use direct substitution. For H, you have a rational function with a limit at infinity. So you want to look for the highest degree in the numerator and denominator and determine the end behavior based on the degrees. And then last, this problem I is a tricky problem because it's not a rational function, but it is a limit at infinity. What you actually want to do is use this as your leading term, and so you have the square root of x squared. The square root of the negative 9 as x goes to infinity becomes so small, it doesn't matter, just like the negative 6 becomes so small, it doesn't matter. So the square root of x squared is x, and the bottom has 2x, and you can go from there based on the comparison of degrees in the numerator and denominator. Treat it like it's a rational function and you were doing the end behavior. I hope that helps.